What is kinematic chain? It is defined as a combination of kinematic pairs joined in a such way that each link forms a part of two pairs and the relative motion between links is completely or successfully constrained. When kinematic pairs are so connected that last link is joined to the first link to transmit a completely or successfully constrained motion, it is called a kinematic chain. The links in a kinematic chain can be either rigid or flexible, and the joints can be either lower pairs or higher pairs, depending on the type of motion that they allow. Before we get in detailed study of the kinematic chain, let's talk about the mechanism. Kinematic chains are used to transmit motion or force between different parts of a mechanical system and can be combined to form more complex mechanisms. They are an important element in the analysis and design or synthesize the mechanical systems, as they play a crucial role in transmitting motion and force within the system. Gears and gear trains, belts and chain drives, cams and followers, linkages, and other moving parts are examples of mechanisms. Different types of kinematic chains. First type is open-loop kinematic chain. Example is robotic arm used in industry or any application. Second type is closed-loop, generally following three types under closed-loop kinematic chains. First, four-bar chain. Second, single slider crank chain. Third, double slider crank chain, and many more. If each link is assumed to form two pairs with two adjacent links, then the relation between number of pairs P forming a kinematic chain present in the mechanism and number of links L present in the mechanism, and this relation is expressed in the form of an equation. L equals to 2 times P minus 4, where L equal to number of links present in the mechanism and P equals to number pairs present in the mechanism. Another relation between the number of links L present in the mechanism and number of joints J present in the mechanism which form a kinematic chain is given by expression J equals to 3 by 2 multiplied by L minus 2, where J is the number of joints present in the mechanism, L equal to number of links present in the mechanism. These expression for L number of links and J number of joints is applied for kinematic chain with lower pair. Then question arise in the mind. What is the relation for kinematic chain with higher pair? Answer is modified form of expression for joints present in the mechanism J plus H by 2 equals to 3 by 2 times L minus 2, where J is the number of joints present in the mechanism, H is the number of higher pairs in kinematic chain, L is the number of links present in the mechanism. Using this equation, we can find or determine whether given mechanism is kinematic chain or not. If left-hand side is greater than right-hand side, it means the chain is locked chain, or we can say its structure which is used in bridges and trusses. If left-hand side is equals to right-hand side, it means the chain is constrained kinematic chain, it satisfy condition. If left-hand side is less than right-hand side, it means that the chain is unconstrained kinematic chain, it's not satisfy condition. Let's find with example case study to check whether mechanisms are kinematic chain or not. Case study 1. 3 links arrangement with 3 links AB, BC and CA which are pin jointed at A, B and C. In this case, L is 3 links, P is 3 pairs, J is 3 joints. If we substituting all values in this equation, we get 3 equals to 2 times 3 minus 4. Left hand side is greater than right hand side. We can also check for another equation relation between joints J and links L. 3 equals to 3 by 2 times 3 minus 2, 3 equals to 2.5. Hence, left hand side is greater than right hand side. It means this chain is locked, it's not kinematic chain, hence there is no relative motion between the links. Such type of chain is called as locked chain, or we can say its structure. Case study 2. 4 links arrangement. These 4 links are AB, BC, C, and AD, which are pin jointed at A, B, C and D, in this case C, and analyze from the figure. L is 4 links, P is 4 pair present in the mechanism, J is 4 joints present in the mechanism. Substituting values in the equations, we get left hand side is equals to right hand side. It means this chain is constrained. It's kinematic chain, which is generally called four-bar mechanism. Hence there is relative motion between the links if definite displacement theta is given to link AB. By keeping link AD fixed, we will get output displacements. These two remaining links, link BC and link CD, are also have perfectly definite motions, means completely constrained motion. As per A.W. Klein scientist equation, the relation between number of links and number of binary joints in order to determine the type of chain is a locked chain or structure kinematic chain, unconstrained chain. Case 3, determine whether the 12-link chain is a locked, constrained or unconstrained kinematic chain. Observe figure. Number of links n equal to 12, number of binary joints equals to 4 at B, C, E, and F. Number of ternary joints equals to 4 at A, D, G, and H. Number of quaternary joints equals to 1 at J. Number of higher pair H equals to 0. Equivalent binary joints J equals to 4 binary joints plus 2 times 4 ternary joint plus 3 times 1 quaternary joint. Equivalent binary joints equals to 15. L is 12, J is 15, H is 0. No higher pair. Substituting values, we get left hand side is less than right hand side. It means that the chain is unconstrained kinematic chain. It's not satisfy condition.
Flow chart of machine starts with rigid or resistant body. It will forms kinematic link that have kinematic pair with relative motions in between them. Then number of kinematic links chain and kinematic pair joints form a mechanism, some mechanism to transmit motion, force to perform any application is machine. Type of joints in a kinematic chain. 3 types of joints generally found in the kinematic chain. First, binary joint. Second, ternary joint. Third, quaternary joint.
Binary joint, if two links are connected at the same end, it is called as binary joint. The figure 1 shows different binary joint of two links. One link is fixed and one link is movable, sliding pair, and piston and cylinder pair. In the figure 2 shows the kinematic chain with two number of binary joints marked as B.
Ternary joint. When 3 links are joined at the same connection, the joint is known as ternary joint. It is equivalent to two binary joints since the fixing of any one link constitutes two binary joints with each of the other two links in this figure. Ternary links are marked as T. Quaternary joint. When 4 links are joined at the same connection, the joint is called a quaternary joint. It is equivalent to 3 binary joints since the fixing of any one link constitutes 3 binary joints. In the figure, the quaternary joint is marked as Q. In general, when L number of links are joined at the same connection, the joint is equivalent to L-1 number of binary joints. Another example shown in the figure, kinematic chain having 11 links. There are 1 binary joint at D, 4 ternary joints at A, C, E and F, 2 quaternary joints at B and G.
Thank you very much for watching full video. Please subscribe, like and share channel. PGK Kadam Academy.